This is the MAT 140 lesson number 11, the Leontif Input-Output Model, and we're looking at the examples that are called the open Leontif Input-Output Models. The example says, a large energy company produces electricity, natural gas, and oil. Production of $1 worth of electricity requires inputs of 20 cents worth of electricity, 10 cents worth of natural gas, and 20 cents worth of oil. Production of $1 worth of natural gas requires inputs of 25 cents from electricity, 15 cents from natural gas, and 10 cents from oil. And finally, production of $1 worth of oil requires inputs of 10 cents from each of the sectors: electricity, natural gas, and oil. So the first question we'll look at, number 1, says, let matrix A be the input-output matrix for this company. This is also called the technology matrix in the notes. So write matrix A. So the way that's done is like this. Okay, so this is the matrix A that I'm going to get from reading off these values, and I will try to explain more and more why it's written this way as we go along. But first, let me just point out where those numbers are going and then begin to work on the explanation. So I see the production of $1 worth of electricity requires inputs of 20 cents worth of electricity, 10 cents worth of natural gas, 20 cents worth of oil. Those numbers are going down this column. Production of $1 worth of natural gas requires inputs of 25 cents from electricity, 15 cents from natural gas, and 10 cents from oil. Those numbers go down this column. And finally, production of $1 worth of oil requires inputs of 10 cents from each sector. So that's that column. As some explanation, let me start off saying that we could label our columns as indicating outputs. They are the variables, and let's introduce these variables: E, G, and L. E for electricity, G for the natural gas, L for the quantity of oil in dollar amounts that are produced by this company. And you can describe the rows as being the inputs needed to make $1 worth of each of these outputs from this company. And so the input amounts in dollar amounts for each of these outputs go down the column in each of these different rows for electricity, for gas, and for oil. All right, so now maybe a little explanation as to what these numbers really mean. Let's take an example. Say for example we wanted $1 worth of electricity and natural gas and oil to be produced. But it takes electricity to generate more electricity, it takes natural gas to produce more natural gas, and it takes oil to produce more oil. It takes all of these resources to produce more of those resources. So let's say we wanted to produce $1 worth of electricity and natural gas and oil. Well, how much electricity would it take to produce $1 worth of electricity and gas and oil? Well, reading off that top row, you could say it takes 20 cents of electricity, 20 cents worth of electricity to produce $1 worth of electricity. And it takes 25 cents of electricity to produce $1 worth of natural gas, and it takes 10 cents of electricity, 10 cents worth of electricity to produce $1 worth of oil. And so adding that all together, it takes 55 cents worth of electricity to produce $1 worth of electricity and gas and oil. That is, it takes 20 cents worth of electricity and 25 cents worth of electricity and then 10 cents worth of electricity all together. That is 55 cents worth of electricity to make $1 worth of all three of these resources: electricity and natural gas and oil, all combined. Let's move on to the second question. Number 2, let I be the identity matrix that's given here. This is the 3 by 3 identity. The identity always has this pattern: ones along the diagonals, zeros everywhere else. That's the identity matrix. So identity matrix is always a square matrix, 3 by 3 or 4 by 4 or 2 by 2. So this is the 3 by 3 identity matrix. The question says, find the matrix I minus A inverse. In other words, find the inverse of the matrix I minus A and use a computer or calculator to do that. So both are good ways to do it, but if you're doing this on a midterm exam, you don't have the computer, you'll have to do it on the calculator. It'd be nice to be able to do both ways, check it on the computer, learn how to use the computer as well. It's a really useful tool, and so it's nice to learn both. I'll do it on both. I'll do it on both ways here on this in this video. So I've copied down the matrix I minus the matrix A that we just found, the technology matrix that we have up here. This is the matrix A. And I've just copied that down here. And I'm going to do I minus A first. I'll find that matrix and then I'll do the inverse of that matrix. So you could certainly use the calculator to do the subtraction, but I think this subtraction is easy enough. I think I could do this in my head. So let's see how well that goes. So I'm just going to subtract component y. So 1 minus 0.2, that's 0.8. 0 minus 0.25, that's a negative 0.25. 0 minus the 0.1, that's a negative 0.1. Now going along the second row, 0 minus 0.1, negative 0.1. 1 minus 0.15, that's 0.85. 0 minus 0.1, that's negative 0.1. And then the third row, 0 minus 0.2, that's 0.8. 0 minus 0.10, that's negative 0.10. 1 minus 0.1, that's 0.9. Okay, so there is the I minus A matrix. The next thing to do, well, the next thing to do is to look very carefully for any mistake at any moment for any reason whatsoever. And sure enough, I was just claiming I was going to do it in my head here, and I missed one. You see that right there? Maybe you caught it. I just caught it. So when I did 0 minus 0.2, I don't get 0.8. I had 0.8 up here because I had 1 minus 0.2, but this is 0 minus 0.2. That's a totally different result. 0 minus 0.2 is negative 0.2 on that entry. Otherwise, everything looks okay. So now we have the actual I minus A matrix that we want to go find an inverse for. So I had put it in and realized it wasn't working, so I have everything typed in except that one I need to fix. It's negative 0.2. Alright, so that's the matrix A that we want to find an inverse. And how do you find an inverse? Well, it's really easy. Exit from the editor, and then I need to identify the matrix, so second matrix, and just get the matrix A by name. I'm using A for this whole entire thing, not the actual A that I was using in the notes. A is this matrix because I just want to type this thing in and get the inverse off the calculator. So to get the inverse, it's just this button right here, this x to the negative 1 button. It's the multiplicative inverse of x, where x is an entire matrix. So just hit that. So there it is. So these are values really that we're just going to need to round off. They're just not practical as rational numbers, as exact fractions. And this many decimal places is just not practical. So let's just copy down maybe 2 places. It didn't really say in the directions how many places, but you know, thinking about this in terms of money, although I don't exactly know how I would interpret that. But let's just go to 2 decimal places. So rounding off to 2 places, I minus A inverse. Well, I can only see the first column the way I have it, so I'm going to put the first column 1.35. 1.35. The next here is If you round to two places, since that's a 6, we'll go 0.20. And then here, the last one, 0.32. Now let's see, on this computer version of the calculator, normally if you just, let's see, well, because I can't get it to scroll, I think if you were on an actual physical calculator, I think if you just go into that, just push up, so that you can actually get the cursor kind of on it to highlight it, and then you could probably scroll over and see it, but it doesn't seem to be working here. So I'm going to have to do this other trick where what I'll do is I'll do second matrix A, and then I'm going to store it in another matrix so that I can go in and edit the matrix but really just look at it. So I'll say I want to take the inverse and I want to store it in matrix B. Let's see if that works. Okay, that looks good. That's the same result. Now if I go back to the editor, matrix editor, and just edit B, I ought to be able to, yeah, perfect. Okay, actually I don't even have to scroll through it. I can see it all. It just rounds it off to fit. So let's say 0.42, 1.25, and then we'll go 0.23. In the last column, again, rounding to two places. That since that third one's a 6, I'll go 0.20, 0.16, and 1.17. And that just answers the question specifically for number 2, is just to find the inverse. Find the inverse matrix find the inverse of the matrix I minus A, right? So here is I minus A, and this is the inverse. And I said I was going to do it on the computer as well, so let's take a look at maybe some other websites that you could use to check this. MatrixCalc is a nice one, although sometimes when I go there the first time it's all in like maybe Russian. I don't know, so I'm going to go to the English version. And yeah, there's a button here for the inverse, so we can just type in the matrix that we just did. You see, this is the matrix that I want to get the inverse of. Oh, yeah, you know what else we could do? We could put the identity in. It's so easy to type in. And then I could go back to the actual matrix, the actual technology matrix. Okay, so I might want to do the identity matrix minus this matrix. So here's the subtraction for that. Okay, that's the result that we had I minus A, and well, I could just insert that in A. So I have that matrix, and then I could find the inverse with this button. And I don't know, we could insert that in B. And also, maybe I want decimal values, just see that it's the same. Yeah, good. That's it. So I could either insert it back in the matrix A or over there in B, but I still want the decimal. Well, maybe it's going to keep the more accurate value as a fraction when it goes up here, and then only display it down here if I wanted it in decimal. So that's really what I wrote down. Right, when we found the inverse of I minus A, we got this, and that checks out perfect. That's exactly it. So, okay, very good. So that's using a website to do the same thing. Maybe it's worth a few minutes talking about what that inverse really is. So just a little bit of the background. So if I go way back to the beginning of algebra, like 3x equal 15, the way you solve is you divide both sides by 3, but you could think of it as multiplying by the reciprocal of that 3 on both sides. We multiply both sides by the reciprocal, that's how we get x by itself, and we have now 15 times 1/3, and we get the answer that way. Suppose that you had 1/7 x equal to 10. The question is, what value would work for x to make this true? Well, you could multiply both sides by the reciprocal of that 1/7, which is 7, and now the 7 and the 1/7, they are multiplicative reciprocals and they cancel, and you solve it that way. So I'm doing something very similar with matrices rather than just a single number, a whole array of numbers, a whole matrix of numbers. Let's just say that in general, if you had this kind of form and you want to solve for x, you could say multiply both sides by the reciprocal. Now, because multiplying a times b isn't the same as multiplying b times a with matrices, I actually have to be conscious of the fact that I'm multiplying on the left here by a inverse, and so I multiply on the left here by a inverse as well. I'm multiplying on both sides on the left, and so these matrix products will still be equal. So whereas before, when you multiply 1/3 times 3, you actually get a 1, and that's a 1-by-1 identity matrix. And here, 7 times 1/7, that's equal to 1. That's like a 1-by-1 identity. So anytime you have A inverse times A, you get the identity matrix, which could be a square matrix, could be 3-by-3 or 4-by-4 or a 10-by-10. But A inverse times A, they are multiplicative inverses. They give you the identity matrix, and so you could just say multiplying these just leaves me with the matrix X equal to A inverse B. So this is another way to solve for X in a matrix equation where X might be itself a whole matrix. So you'll see that generally this matrix X, this X could be a matrix, and A inverse, that's a matrix, B is a matrix. Depending on the dimensions of A and B, that affects the dimension of the matrix X. So I have to point out also, by the way, that this would only work if there is an inverse. Some matrices don't have inverses, and if there isn't an inverse, you couldn't use this method to solve. You wouldn't be able to find the inverse, so you couldn't solve using the inverse. In other cases, when there is no inverse, we use the Gauss-Jordan method for solving as one method that would work even when there's no inverse. So sometimes you could use either method, Gauss-Jordan or find an inverse, and it just depends on the situation which one is more convenient. Maybe generally the kinds of examples that we see, you can use either one as long as there's an inverse, and so it's just one other additional approach for solving a system. So let's see how we can use that general theory there to answer this last question. Number 3, find the output of electricity, natural gas, and oil this company must produce in terms of the dollar amounts to satisfy a demand of $50 million in electricity, $9 million in demand for natural gas, and $15 million in demand for oil. Use the computer or the calculator to solve to find that output of each of the three quantities. So we'll do it both on the computer and the calculator here. All right, let's see how that works. Okay, so for this kind of question, we'll take this approach. We'll go back to that original matrix that we wrote from the given statement of the question, that A matrix from the very beginning in question 1. We call it the technology matrix. You have to find that first, and then we write this thing that you call the technology equation. I think the word technology, this is kind of an older economics concept that probably the word technology has kind of changed to where we really think about like high tech. Now when you say technology, you mean computers and basically high tech. But this was technology in a more general sense about production. Okay, in the early economics. So okay, so imagine that you have some company or some economy that has some production, the total gross production represented actually by a matrix. okay, this is the production of all these different quantities in the economy, by the company, like our company, our example here, they produce electricity and they produce natural gas and they produce oil, but it still takes electricity, natural gas, and oil to produce all those products. So this is the actual amount that they'll produce. But then in the process of producing all those resources, they use some of those resources, and so that's what's subtracted from the gross production based on these coefficients that represent the fractions of each resource that are needed to produce $1 worth of the gross production. And so when you take the gross production, you remove what was required that was consumed in the production. What's left is the surplus that fulfills the demand. It's what the company can then sell, for example, to its consumers, and that's this matrix D. So we're actually going to solve for the matrix X as the production level that the company would need to make in order to fulfill the demand that they want to meet. So we will essentially be given the matrix A and given the matrix D, and we solve for X. So that is, given the matrix A and D, we'll solve for matrix X, which represents the outputs for each resource needed to meet this given demand. So we want to satisfy a demand of $50 million worth of electricity, $9 million worth of demand in natural gas, and we need $15 million in oil. And we have a given technology matrix, that is to say we know how much of each of these resources it takes to make more of these resources. Let's write the technology equation. Alright, so we were given the technology matrix A that's here, and we have demand that we want to meet of 50 million for electricity, 9 million for natural gas, and 15 million for oil. And so we could put that together as an equation. The equation takes that form. But actually, before we solve, the nice trick that you can do here is actually factor out the x and factor it out to the right, because then I could multiply both sides by the inverse of this matrix. If you found this inverse of this matrix, you have to multiply on the left, because I multiplied on the left here to cancel these guys. I have to multiply on the left there. So these guys cancel, and the output production amounts in dollars, actually in this case in millions, because D is in millions, how much do we have to produce in millions of dollars worth of each of the resources would be given by this. Now we've already figured out what I minus A inverse is in this particular example, so that was, and we know what D is, 5915. So we could certainly do that by hand, but it's very easy to put that into a calculator or computer, so let's do that. So I happen to already have this matrix B on the calculator, so let me just put this in as matrix C, and then I can just multiply them. So matrix C is a 3-row, 1-column, 3 by 1. I just check to make sure matrix B is what I thought. Matrix B is exactly, actually, so what I have here is something a little more accurate than what I actually wrote down. So I'll be multiplying this more accurate value, so there might be slight differences depending on whether you use exactly these numbers or the numbers that I have in the calculator here. When I multiply these, I want to do B times C, so let's do that. So matrix B multiplied with matrix C. And okay, let's round off maybe 2 places. 74.33, 23.55, 38.80. So x is those three values all together. Those are the components of this 3 by 1 matrix that actually represents the amount in millions of dollars that are needed to be produced of each of the resources. So that's it. We want to produce 74.33 million worth of electricity, $23.55 million worth of the natural gas, and $38.81 million worth of oil to meet the demand. Notice, by the way, for example, that the demand was 50 million for electricity, 9 million for natural gas, and 15 million for oil. We had to produce a good bit more than that because in the production it uses each of these resources. So these things should be higher than the demand level that you are expecting to have at the end of the production. The amount that's available for demand, the surplus that is available as demand, will be less than the amount of that we have to create as outputs into the system. These are the outputs. These have to be bigger because in the process of producing all of those resources, we use some of those resources, and therefore we'll end up with a little bit less, or maybe a lot less, as is the case here. All right. So that's how you do that one. That's the end of that video. I hope it's been helpful.